Assalamualaikum warahmatullahi wabarakatuh. My name is Raida binti Rashidi and my metric number is 2112866. In this video, we are going to explain about our group project entitled Association between Screen Light from Devices and Sleep Quality. These are my team members' names. Introduction. Good sleep leads us to good health. Nowadays, everyone rely on their phone. Even before sleep, people will still look at their phone. We constantly pump information into our brains. So, when it is time to switch it off, we should also do the same with our phones. But do they know it is bad for our eyes and sleep quality when we look at our phones before going to bed? Blue light from electronic screens is the worst of all the colors. So, we conduct this project to study the relationship between screen light from devices and sleep quality. Students often work with their gadgets most of the time and they are exposed to screen light for a long time. Studies have shown that exposure of screen light from devices affect the body. So, we are conducting this research to see whether screen light from devices better for sleep quality or not. The problem statement for this project is, how does screen light from devices affect your ability to sleep?
Assalamualaikum, my name is Csci1304 G5 and my metric number is 2114488. I will continue with the hypothesis for our group project. So logically, those who frequently faces the screen devices will get low quality of sleep. It makes sense that those who stare at screens a lot during the day will have poor sleep. The use of screens is associated with a variety of insomnia symptoms. Screen usage delays melatonin release, which delays bedtime and results in less peaceful sleep. The majority will be getting less total sleep and being more sleepy the next day. Okay, next is the method that we use. Firstly, the data was collected based on the different places and people. We are collecting this data by online survey at Google Form. On the survey, the respondent was asked to answer a few questions that related to our research. We are using the inferential statistics method. From the data collected, we use the variance and standard deviation to determine the spread of the data and the consistency of a variable. So, to determine the number of data values that fall within a specific interval in the distribution, we are using Chebyshev theorem. Okay, so this slide portrays the relationship between duration of spending time with gadgets and night mode screen usage. So, from these three pie charts, we can see the frequency spending time with gadgets for people that never use the night mode screen, sometimes use and always use the night mode screen.
Bismillahirrahmanirrahim. My name is Muhammad bin Abbas and I will continue for my part, which is for our data, the relationship between night mode screen usage and easiness of people to sleep at night. And we have grouped this data into three pie chart, which is the first, frequency of easiness to sleep for people that never use night mode screen. Second is frequency of easiness to sleep for people sometimes using night mode screen. And lastly, frequency of easiness to sleep for people that always using night mode screen. So for the next is the relationship between night mode screen usage and sleep quality, and we have grouped it into three subcategories, which is first is the frequency of sleep quality for people that never use night mode screen. Second is frequency of sleep quality for people that sometimes using night mode screen, and lastly is the frequency of sleep quality for always using night mode screen. So for this part, this is our histogram about the time spent with gadgets and sleep quality, which is the time spent with gadget. We have provided 6 subcategories, which is 1 to 4 hours, 5 to 8 hours, 9 to 12 hours, 13 to 16 hours, 7 to 20 hours, and 21 to 24 hours. And for the sleep quality, we have put in the variety of color, which is in score. For the score of 1, which is the dark blue, for the score of 2, which is orange, for the score of 3, which is grey, and for the score of 4, which is yellow, and for the score of 5, which is the light blue. So for this part, we have list 4 type of calculation, which is mean, mode, median, standard deviation, and 1 type of distribution shape, which is either skewed to the left or skewed to the right. And for this duration of 1 to 4 hours, we have mean 3.67, mode and median 4, standard deviation is 0.57, and it's skewed to the left. For the duration of 5 to 8 hours, we have mean 3.48, the mode and median is 4, the standard deviation is 1.05 and it's skewed to the left. For the duration of 9 to 12 hours, we have mean 3.31, the mode is 3 and the standard deviation 0.93 and it's skewed to the right. For the duration of 3 to 16 hours, we have mean 3.38, mode and median is 3, the standard deviation is 0.86 and it's skewed to the right. And for the duration of 7 to 20 hours, we have mean 3.45, the mode and median is 3, the standard deviation is 0.82 and it's skewed to the right. And lastly, the duration of 21 to 24 hours, the mean is 3.67, the mode is 3 and the median is 3.5, the standard deviation is 0.82 and it's skewed to the right. And for the dispersion measurement, we have concluded that the greatest dispersion among this is the duration of 5 to 8 hours, which we have the standard deviation of 1.05. So this is our histogram table for the night mode screen usage and sleep quality, which is our screen usage. We have provided the never use this night mode screen usage, sometimes use, and always use night mode screen usage. And we have provided a score of 1, 2, 3, 4, and 5. And we have concluded that there are a lot of person that have a moderate sleep quality. So for this part, we have also list the 4 types of calculation, which is mean, mode, median, standard deviation, and also for the distribution shape, which is we have put either skewed to the right or to the left, and also the data is uniform. And for this never use night mode, we have mean 3.05. The mode and median is 3, the standard deviation is 1.16, and we have concluded that the data is uniform. And for this sometimes use night mode, we have mean 3.36, mode and median is 3, the standard deviation is 0.81, and it's skewed to the right. And for always use night mode screen, the mean is 3.45, the mode and median is 3, then the standard deviation is 0.85 and it's skewed to the right. And for the dispersion measurement, we have concluded the greatest dispersion, which is the never use night mode with the standard deviation of 1.16.
Okay, my name is Ahmad Hazim bin Muhammad Aziz, and I will continue with my part about preliminary analysis. This is about analysis on category. So it's about analysis on category, night mode screen usage and sleep quality. So based on this graph, we have 3 categories. First is about people never use night mode screen. Second, they sometimes use night mode screen, and the last is about category on always use night mode screen. So from the graph, we know that people who always use night mode screen have a better sleep quality. So from the data that we have, after we made a survey about it, I made several calculations to find a mean, mode, median, and lastly standard deviation. So for the never use night mode, the mean is 3.57, the mode is 4, median 4, and standard deviation is 1.22. So always use night mode, mean 3.52, mode 4, same with median 4, and standard deviation is 1.15. And last, sometimes use night mode, the mean is 3.2, mode and median is same is 3, and standard deviation. So from the data, the largest mean we have is 3.57, and it's never use night mode, and the least is sometimes the least mean we have is on sometimes use night mode category, that 3.2. So the largest spread is standard deviation. The largest spread is 1.22, also on category never use night mode. Okay, so second is about analysis on category, time spent with gadget and sleep easiness. So this is the graph that we have. So this is the graph we have from the data that we get from the survey we made. Okay, from that we analysis to 6 different category about their duration spending with gadget. So the first category is duration of 1 to 4 hours, second is 5 to 8 hours until 24 hours. So the largest mean is on duration 1 to 4 hours with value 4.67, and the least is on the duration of 5 to 8 hours that spend this time with gadget, which is the value 3.07. Okay, then this is about the largest spread. The largest spread is standard their standard deviation. So the largest standard deviation is 1.36. It's on duration of 5 to 8 hours.
This is the bar chart for night mode screen usage and easiness to sleep. From the bar chart, we can analysis to 3 different kinds of night mode usage, which is never use night mode, always use night mode, and sometimes use night mode. For the highest mean of night mode usage is the never use night mode, which is 3.57, and the least mean is for sometimes use night mode with 3.20. The highest standard deviation is for never use night mode with 1.22, and the least standard deviation is sometimes use night mode with 1.02. Assalamualaikum, my name is Amir Al-Wafiq and I will be continuing this presentation for the 5.0 random test. In this test, we will be executing the runs test to determine the randomness of our data collection. The runs test is used to determine if a sequence of data values occurs at random. Therefore, this test will prove that the data we obtained from the sample are truly random. As we know, in the runs test, when n1 and n2 is bigger than 20, we must use the formulas for the test statistics value in order to perform the test correctly. These are the formula for the run test, where z is the essential as it is the test value that we want to compare to the critical value. Our null hypothesis is that the arrangement is random, and our alternate hypothesis is that the arrangement is not random. To find the critical value, we must find n1 and n2. n1 represents the number of items in category 1, which is male, and n2 represents the number of items in category 2, which is female. In our project, there were 57 males and 43 females, hence n1 equals to 57 and n2 equals to 43. With 0.05 significance level, and by referring to table E, we will find the critical value equals to plus minus 1.96. 40 is used to denote the number of runs, which is G. After we plug in the formula, we will find the test value equals to minus 1.7688, which we will round it up to minus 1.77. Since the test value minus 1.77 is in the range of the critical value plus minus 1.96, the decision is to not reject the null hypothesis. There is not enough evidence to reject the hypothesis that the arrangement is random. Therefore, this proves that our data is collected randomly.
Limitation and weakness. First, small number of respondents. Second, non-scientific measure. Third, different background. And lastly, fixed range of score.
We are humbly hoping that our research could give some benefits to other people, even if it is just a small part of the community. As for the next research, we are recommending to gather more respondents so that the result will be easier to analyze and interpret. The method used to collect data also needs to be refined. We must use quantifiable methods to evaluate the quality of something to avoid bias in the result and also to improve the precision of the data itself. The scale also can be bigger so that the user can express their answers in more details, thus providing more convincing data for the study. Assalamualaikum, my name is Muhammad Ashraf bin Abid, metric number 2116857, and I will conclude this presentation for my group. So after collecting the data required and finalizing the result of the study, it turns out that the results are corresponding with our hypothesis, which is the less screen exposure that someone gain, the better the quality of sleep that the person is going to have. Other than that, we also found out that people who are using the dark mode on their devices are highly likely to have a better sleep quality and also easier sleep at night. Unfortunately, the study that we conducted has its own limitations and weaknesses that may influence the reliability and validity of our findings. So that's all from us. Thank you.